Hello students, we are solving the IB Math AHL past papers, and from today we start to solve the IB Math AHL May 2022 paper 3 time zone 1 past paper. Today we will be solving the question number 1 of this paper, and in our coming session we will be solving the question number 2 of the same paper. And you will be getting the links to all the previously solved questions of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 1. The maximum marks is 27. And it is saying this question asks you to explore some properties of polygonal numbers and to determine and prove interesting results involving these numbers. So, what is a polygonal number? A polygonal number is an integer. It is an integer which can be represented as a series of dots arranged in the shape of a regular polygon. Triangular numbers, square numbers, and pentagonal numbers are examples of polygonal numbers. For example, a triangular number is a number that can be arranged in the shape of an equilateral triangle because it has to be a regular polygon. It has to be a regular polygon, so it will be in the shape of an equilateral triangle. The first 5 triangular numbers are 1, 3, 6, 10, and 15. The following table illustrates the first 5 triangular, square, and pentagonal numbers respectively. In each case, the first polygonal number is 1, represented by a single dot. So these are the triangular numbers. This is the first triangular number 1. This is an equilateral triangle consisting three dots. So the second triangular number is 3. Third triangular number is 6. You can count the number of dots over here 1, 2, 3, 4, 5, 6. So this is the third triangular number, and you see for the first triangular number it is just a single dot, it is a single row. For the second triangular number you are having 2 rows. For the third one you are having 3 rows. For the fourth one, 4 rows. For the fifth one, it is you are having the 5 rows. Okay. So what will be the sixth triangular number? For that we have to create the sixth row. Let us create the sixth row. 1, 2, 3, 4, 5, and 6. So there are 6 dots in the sixth row. So the sixth triangular number will be, there are 15 dots in the fifth diagram. So 15 plus 6 is 21. Therefore, the sixth triangular number will be 21. This way you can get the succeeding triangular numbers. Okay. For the square numbers, all are squares. As the name suggests, all are squares. 1 square, 2 square, 3 square, 4 square, 5 square, and so on. Okay. And also for this, you see the first number 1 row, second number 2 rows, third number 3 rows, fourth number 4 rows, fifth number 5 rows, 1, 2, 3, 4, 5. Okay. Now coming to pentagonal numbers, you are again having the first 5 pentagonal numbers as 1, 5, 12, 22, 35, and so on. Okay. So now let us go to the questions. For an R-sided regular polygon, R-sided means for a triangular number, the R value will be 3. For a square number, the R value will be 4, and so on. Where R is an element of the set of positive integers, and R is having a value greater than or equal to 3, the nth polygonal number PR of n. Now, what is the meaning of nth polygonal number? Like if we take the case of triangular numbers, in case of triangular numbers, the R value is equal to 3. And the first triangular number is 1. So we will be writing PR of 1. So over here, the n value is equal to 1. For the first number, this is equal to 1. The second triangular number, this should be 3. P3 of 1 is equal to 1. And this is P3 of 2, that is the second triangular number. This is equal to 3. You have seen that. And the third triangular number is 6, and so on. So the R value is equal to 3 because we are dealing with the triangular numbers. And what is n? N is giving the position of the number. It is not giving the value of the number, rather it is giving the position of this one in the series of triangular numbers. 1 is holding the first position in the series of triangular numbers. 3 is holding the second position in the series of triangular numbers. Okay. So PR of n is equal to r minus 2 whole multiplied by n square minus r minus 4 whole multiplied by n and whole divided by 2, where n belongs to the set of positive integers. Fine. And are writing hence for square numbers where r is equal to 4, p4 of n, they have just substituted 4 in place of r. So it is 4 minus 2 whole multiplied by n square minus 4 minus 4 whole multiplied by n whole divided by 2 is equal to n square, because 4 minus 4, this part is equal to 0, and 4 minus 2 is 2, this 2 and this 2, they will be getting cancelled, and we will be having this expression as n square. Okay. Now coming to the first subpart A, it is containing 2 further subparts. The I subpart is saying for triangular numbers, that means r equal to 3, verify that P3 of n equal to n times n plus 1 over 2. So we will be using this formula. So AI is P3 of n. So we will be writing 3 in place of r. Okay. 3 minus 2 whole multiplied by n square minus 3 minus 4 whole multiplied by n whole divided by 2. And what is 3 minus 2? It is 1. So this is equal to P3 of n equal to n square. 3 minus 4 is negative 1, and there is this negative sign in front. So negative of negative 1 is positive 1. So positive 1 times n is positive n. So n square plus n divided by 2, or I can take n common. It is n times n plus 1 divided by 2. Okay. So verify it. Okay. Coming to II. The number 351 is a triangular number, and determine which one it is. That means you have to find the value of n. Okay. You have to find the value of n. I hope you are being able to see this formula. Okay. So we can write, this is the general formula. We have in fact got the formula for the triangular number. So in this case, we will be using n times n plus 1 over 2. Not the previous one. We can use this, but ultimately again we will be coming to this point. So I am using this formula. So n times n plus 1 over 2 is equal to 351. Or I can multiply both sides by 2 to get n times n plus 1, and it will be equal to 702. Okay, you can use your calculator. It is 35 times 2 is 70 and 2 times 1 is 2. So it is 702. And this will be a quadratic equation. So let me just expand. Is n square plus n minus 702 equal to 0, and we have to find the value of n. So let us go to the calculator. Okay, and we go to algebra, and it is the polynomial tools. Degree is 2. Find it was n square plus n minus 702. So the coefficient of n square, that is in this case x square, is 1. Coefficient of x is also equal to 1, and the constant term is 702. Okay, enter. And we are getting the two values of n because it is a quadratic equation. We will be getting two values, and one is negative 27 and the other is 26, positive 26. Therefore, n equal to negative 27 or n equal to positive 26. And since n belongs to the set of positive integers, n equal to negative 27 cannot be taken. So the 26th number, 26th triangular number is 351. Therefore, 26th triangular number is 351. Okay. Subpart B. It is containing 3 subparts. Subpart B. It is containing 3 further subparts. And over here we are having the expression for P3 of n that we had verified previously in subpart A, and this is the P4 of n equal to n square. They had just shown in place of r, they had substituted this value of 4. Okay. So P4 of n was equal to n square. This is not needed right at this moment for answering subpart I. The subpart I is saying show that P3 of n plus P3 of n plus 1 is equivalent to n plus 1 whole square. So what was n? What was n representing? N was representing the position of this number in the triangular number series. So this number is holding the nth position and this number is holding the n plus 1th position. So that means these two are two consecutive numbers. Okay. Well, let us just use this expression to start answering I. P3 of n plus P3 of n plus 1 should be equal to P3 of n is n times n plus 1 over 2. And P3 of n plus 1 is, we will be substituting n plus 1 in place of n. So it is n plus 1 and n plus 1 plus 1 over 2. Okay. So this is equal to, we are having the common denominator as 2. So let me write 2 here. And this is n times n plus 1. And that is n plus 1 and n plus 2. Yeah. So now we can take n plus 1 common. So it is n plus 1 and n from here and n plus 2 from that side. Which is n plus 1 and 2n plus 2 over 2. And I can take 2 common from here. So this is 2 times n plus 1 times n plus 1 over 2, and these two will be cancelling. So we are having n plus 1 whole square. Okay, shown. Now we come to II. State in words what the identity given in subpart BI, that is this one, shows for two consecutive triangular numbers. It is showing that when we are adding two consecutive triangular numbers, we are getting the square number and its position is n plus 1 position. Okay, when we are adding two triangular numbers holding the positions n and n plus 1, we are getting a square number which is holding the position n plus 1 in the square number series. Okay, so we will be writing exactly that thing. Then we add two consecutive triangular numbers holding positions n and n plus 1 in the triangular number series we get a square number which holds the position n plus 1 in the square number series. Okay. Now we come to III. Let me see, what did I write once more? When we add two consecutive triangular numbers holding positions n and n plus 1 in the triangular number series, we get a square number which holds the position n plus 1 in the square number series, right? So I is for n equal to 4. Sketch a diagram clearly showing your answer to the part B, I. Okay, this is I. Now, I'm starting from n equal to 1. Okay, I'm taking n equal to 1 and n equal to 2, just for the sake of explanation, first of all. Afterwards, I'll be going to n equal to 4. I have to go. But there to answer this. So, this is n equal to 1 and this is n equal to the second triangular number. It is this. Okay. So, if I add these two triangular numbers, I should be getting a square number, which will be the second square number. So, how can I get a square number if I add this dot over here? See, this is a square number, and the shape, it is of course a square, but it looks like a rhombus. So, in order to make it look like a square, this is a rotated square. So, we will be having it as a perfect square the way we see a square in this form. Okay. So for that, instead of drawing this equilateral triangle in this way, if I draw the equilateral triangle in this way, this is not a right angle triangle. This is still an equilateral triangle, but drawn in this way, rotated. And then this is the second triangular number. And to this, if I add the first triangular number, I add this dot over here. This becomes the second square number. And now it is appearing to be a square. Okay. So what do? We can come over here. I am taking n equal to 4. So I will be drawing the fourth triangular number. This is 1, 2, second row, n equal to 4. So we will be having 4 rows. 3 and 4. Okay. So this is n equal to 4. This is the fourth triangular number. And so since n equal to 4, therefore n plus 1 should be equal to 5. Okay. We are adding. So this is the fifth triangular number. Third row. Fourth row. And fifth row. Okay. So this is the fifth triangular number. Now we have to add these two and I have to make a square. So this should be equal to, this should be equal to, first of all, I am drawing the larger one. Okay. This is 1. This is second row, third row, fourth row, and fifth row. Fine. Now I have to add this, this to this so that I get a square. How can I add this? See, this is of the shape. I'm not using the word rotation consciously. I'm just showing that this is of this shape and I have to just rotate it to get this shape. So I start from the bottommost row. It is containing 4. So let me draw the 4 dots over. Okay. Then the second last row, 3 dots. Second row, 2 dots. Two dots. And finally, the topmost row, one dot. Okay. Now you see it appears to be more or less like a square. Okay. If not exactly a square, almost a square. So, and what is this? How many dots is this figure containing? 1, 2, 3, 4, 5, and there are 5 dots. So 5 times 5, 25. So this will be the fifth square number. This is P4 of 5, which is equal to 5 square or 25. Okay. This was n equal to 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 and this was plus, this was 15. So 10 plus 15 is 25. This is what you have to show. Okay. I hope you are being able to see. This is the diagram. This is n equal to 4. This is n plus 1 equal to 5. That is, this is the fourth triangular number. This is the fifth triangular number. If you add them, you get this square, which is the fifth square number. It is containing 25 dots. It is 5 square, so it is containing 25 dots and is the fifth square number. Okay, so this should be the answer for this III. The part C. Show that 8 times P3 of n plus 1 is the square of an odd number for all n belonging to the set of positive integers. And this is a triangular number and the expression for any triangular number is n times n plus 1 over 2. Fine. So let us start answering this part C over here. So 8 times P3 of n plus 1 is equal to 8 times n times n plus 1 over 2 plus 1, and this will be getting cancelled and it is 4. So I can just expand this part. It is 4n square plus 4n and plus 1. So, which is nothing but 2n plus 1 whole square. Let me show you. This is 2n whole square. This is 2 times 2n times 1 and plus 1. So this is equal to 2n plus 1 whole square. And since 2n plus 1 is an odd number, for all n belonging to the set of positive integers. Therefore, eight times P3 of n plus 1 is the square of an odd number. Okay, shown. Define. Now we come to this portion, the pentagonal number portion. The nth pentagonal number can be represented by the arithmetic series P5 of n equal to 1 plus 4 plus 7 plus dot 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 plus Pn minus 2. Okay. So, part D's question is, hence show that P5 of n equal to n times 3n minus 1 over 2 for all n belonging to the set of positive integers. Okay, fine. So, we will be taking the series. It is an arithmetic series. So, this is part D. P5 of n equal to 1 plus 4 plus 7 plus dot 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 plus 3n minus 2. Okay. So, we are seeing the first term is 1 and the common difference is 3. So, first term u1 is equal to 1. Common difference equal to 3. Fine. And if you are not sure about how many terms are there in this series, we can find out. Okay, so we will be writing, let me do this calculation of finding the number of terms over here. So this is 3n minus 2. This should be equal to u1 plus n minus 1 times 3. And this is what? This is un. Un, the formula for un is u1 plus n minus 1 times t, right? And if you just expand this, you will be having 1 plus 3n minus 3, which is equal to 3n minus 2. So 3n minus 2 is the nth term, is un. So this is the nth term. Therefore, there are n number of terms in the series. The first term is 1, the common difference is 3, and the last one, the nth term, is 3n minus 2. So it is an arithmetic series. We will be using the summation formula. Therefore, P5 of n is equal to, there are n number of terms, so n over 2. The first term is 1 and the last term in this series, it is actually the nth term. So it is 3n minus 2. You can take the formula to u1 plus n minus 1 times t as well. You will be getting the same expression. So 3n minus 2 equal to n over 2 and Pn minus 1. So P5 of n is equal to n times 3n minus 1 over 2. Shown. Okay. Part E. By using a suitable table of values or otherwise, determine the smallest positive integer greater than 1 that is both a triangular number and a pentagonal number. The triangular number expression is n times n plus 1 over 2, and the pentagonal number expression is n times 3n minus 1 over 2. Okay, we had shown both of these two. And well, you may use the calculator. So you have to, in fact, the answer to subpart E. You should be making 3 columns. One will be n, and this will be P3 of n, and the third column will be P5 of n. Okay. So you can start by this is 1, 1, 1, and so on. You will be having. You have to use the calculator. Now, one mistake that some students make is they say that they feel that because the number is common, this is a number, this is a number, and you are having the same number in the as the triangular number and as the pentagonal number. They just equate these two expressions, but it is wrong, because the third triangular number, it is not written anywhere that the third triangular number will be equal to the third pentagonal number. Okay, the third pentagonal number may be equal to the sixth triangular number, or whatever it is. I don't know what will be the common number. Okay, I have no idea. But the n value will be different. This is the expression for the nth number of the triangular series, and this is the expression for the nth number of the pentagonal series. But the n value will not be the same. The number will be the same, but their position will not be the same. So you cannot equate these two expressions. You have to use the calculator. We go to the calculator, and then we have to go to the, in fact, to the spreadsheet. Okay. So this is n P3 P3n, and this one is P5n. Fine. So these are the 3 columns. First one is 1. This is 1, 1. And then the n values will be going on increasing in steps of 1. So it will be, the first value is stored in the A1 cell. So it is A1 plus 1. Enter. So let me just go on. Don't know how. Or will I be? Okay, 60 or 75 I have taken. Fine. I come to this place. Again, I'll be entering a formula. So it is equal to, and for the triangular number, it is n times n plus 1 over 2. And n value is stored in A2 cell. So it is A2 times A2 plus 1 over 2. Enter. 3. Fine. Let it be. And coming to the pentagonal, equal to, Again, the n value is stored in A2 cell, so A2 equal to stored in A2 cell, okay, times P times A2 and minus 1. Fine, and this one is 2. Enter. Should be. Fine. The pentagonal numbers are larger. Let us check. Let us see the pentagonal numbers and okay, let us start from 12. 12, we are not having any 12 in the triangular series. 22, we are not having 35. We are not having 51. We are not having 70. 70. We are not having 92. Definitely will not be having 117. 117 we are not having. Then 145. 145, no. 176, no. 176, 210. Yes, we are having 210 in the triangular number series, and we are having 210 in the pentagonal number series. 210 is the 20th triangular number. Okay. What are they saying? I'm not writing the values. It is containing 5 marks. So you have to just copy the 3 columns. I'm not copying. It will be taking some more time. So I'm just skipping this part. I have drawn the 3 columns. You have to just write the values and so on. You have to just copy them. And determine the smallest positive integer greater than 1, that is both a triangular number and a pentagonal number. So answer will be 210 is both a triangular number and a pentagonal number. $210 is the 20th triangular number let us see its position in the pentagonal column. Okay, it is the 12th. See, n value is equal to 12. For triangular number, it was 20. N value equal to 20. And for pentagonal numbers, n value is equal to 12. Okay. So 210 is the 12th pentagonal number. Okay. Polygonal number PR of n can be represented by the series sigma m equal to 1 to n 1 plus m minus 1 times r minus 2, this whole expression, it will be getting added for different values of m. The starting value of m is 1 and the ending value of m is n, where r belongs to the set of positive integers and r is greater than or equal to 3. And the subpart F's question is use mathematical induction to prove that PR of n, in fact, this was the very first expression that they had given. PR of n equal to, and remember, then they had written P4 of n, they had just substituted 4 over here. So PR of n equal to r minus 2 whole times or multiplied by n squared minus r minus 4 whole multiplied by n whole divided by 2, where n belongs to the set of positive integers. Okay, so as we do, first of all, let us check for n equal to 1, the very first number. So we are when n equal to 1, the series PR of 1 will be equal to n equal to 1. So the series will be m equal to 1 to 1, because in place of n I am writing 1, and 1 plus m minus 1 and r minus 2. So this is equal to, in place of m I'll be writing 1. So 1 plus 1 minus 1 times r minus 2, and 1 minus 1 is 0. So this is equal to 1. Okay. And coming to this formula, this is the summation. From the summation, we are seeing PR of 1 is equal to 1. And from this formula, what are we getting? PR of 1 is equal to r minus 2, 1 square minus r minus 4 times 1 over 2. 1 square is 1, so this is r minus 2. And r minus 4 times 1 is r minus 4, and there is a minus sign in front, so it will be minus r plus 4 over 2. These two cancel, and 4 minus 2 is 2. 2 over 2 is equal to 1. So using the summation expression, PR of 1 is 1. Using this expression, PR of 1 is 1. Therefore, true for n equal to 1. Okay. Now I am coming to this part. Okay. So let it be true for n equal to k. Therefore, PR of k, first of all, let me write the summation thing. It is m equal to 1 to k. In place of n, I am writing k. It is 1 plus m minus 1 times r minus 2. This should be equal to, in this expression also, I'll be putting k in place of n. So this should be equal to r minus 2 k square minus r minus 4 times k over 2. This is true. Okay? So I can just for the sake of explanation, I can just show what does this mean. This is the summation sigma. There is the sigma thing in front. So I will be taking uh, one value of m at a time for each term. So the very first term will be having the m value as 1. So it will be 1 plus 1 minus 1 times r minus 2 plus 1 plus 2 minus 1. Now the m value is 2. So 2 minus 1 times r minus 2 plus 1 plus 3 minus 1 times r minus 2 plus dot 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 plus 1 plus a minus 1 times r minus 2. This should be equal to this. R minus 2 times k square minus r minus 4 times k over 2. Okay. Now we come to n equal to k plus 1. So when n equal to k plus 1, PR of k plus 1 should be equal to, I'm taking the summation series, this one. This should be m equal to 1 to k plus 1 and 1 plus m minus 1 times r minus 2. Now, if I just expand like I have done before, what do I get? The first term will be the same. It will be 1 plus 1 minus 1 times r minus 2. Thus, the second term will also be the same. 1 plus 2 minus 1 times r minus 2. The third term will also be the same. I am not writing the third term. It is plus dot 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 plus plus. I'm writing directly. I'm coming to the kth term. That is this one. 1 plus k minus 1 r minus 2. Now I am coming to the m equal to k plus 1. That will be the last term. Okay. Plus 1 plus, in place of m, I'll be writing k plus 1. So k plus 1 minus 1 and r minus 2. This is the expansion. Okay. Now, if we take the first k terms, this is nothing but PR of k. Okay. This is nothing but these terms. The k terms starting from this term to this term, which was equal to this. Right. So this can be written as r minus 2 k square minus r minus 4 k over 2 plus, I have to write this term, plus 1 plus k plus 1 minus 1 is k. K r minus 2. Okay? And let me just write it over here. Let me just check what do I have to prove. What expression should I be getting? Okay, let us just get that. PR of k plus 1, let me just write it in separate color. PR of k plus 1 should be equal to, see, over here, r minus 2 and k plus 1. I have to write it from the little bit from the left side. So this is PR of k plus 1. This should be equal to r minus 2 k plus 1 whole square minus r minus 4 times k plus 1 over 2. So I should be getting this expression. Okay? I should be getting this expression from here. So this is equal to, so because this is PR of k plus 1. So this is equal to, okay, I can just make this 2 the common denominator. Let me make the 2 the common denominator because I need the 2 as the common denominator. So I can write r minus 2. I'm not opening this, I'm not expanding this because I need r minus 2. I am having r minus 2, I'm having r minus 4. So I'm not opening these. So at least let me keep the first one. If I need to open the second one, I'll be doing that. R minus 2k square minus r minus 4k, and I'm multiplying this with 2 because I'm writing this as this in this form. Okay, so it will be plus 2 and plus 2k r minus 2 over 2. So this will be equal to what? I can take r minus 2 common. I'm taking r minus 2 common, and I am having k square from this part and 2k from this part. And I need k plus 1 whole square. So if I have a plus 1, then it will be k plus 1 whole square. So I'm just inserting, I'm just uh, adding this term extra. So if I write 1 over here, that means what did I add? I have added r minus 2 times 1. That is, I have added r minus 2. So since I have added r minus 2, I have to subtract r minus 2. So this is minus r minus 2 and okay plus 2, and this is remaining. This is minus r minus 4 times k over 2. So this is r minus 2 and k plus 1 whole square. Fine. And this part is what? This part is minus r plus 2. And this is plus 2. So this is minus This is in fact minus r plus 4, which can be written as minus r minus 4 because I need r minus 4. Okay. So this whole part can be written as minus r minus 4. So I am writing minus r minus 4. And from here I am getting k. And from this part it is just minus r minus 1. So minus r minus 4 times 1. So it is plus 1 because this can be written as times 1. So from this part I am getting 1 and from here I am getting k. So this is over 2. Okay. So this is equal to PR of k plus 1. See, r minus 2 times k plus 1 whole square minus r minus 4 times k plus 1 divided by 2. Okay, so verify it. Therefore, it is true for PR of n plus 1 whenever it is true for PR of n belonging to the set of positive integers. Okay, over here also I have to write let it be true for n equal to k. K belongs to the set of positive integers. You have to write this part. Okay. So whenever it is true for PR of n and n is an element of positive integer set and also PR1 is true. Okay. I have not written therefore by mathematical induction because I don't know whether I can write another line below this line, but I don't know. I'm not sure whether you'll be able to see that line. So I have ended over here. You can write therefore by mathematical induction. We have proved. So now this ends this question number 1 of paper 3, and we have solved. We have completed solving this question number 1, and we'll be solving question number 2 in our next session, in our coming session. Thank you for staying with me till the end. And I am Nilanjana Sanyal. I am an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India. And uh, I would like to ask you a question. Are you liking my explanations? You have stayed till the end, so I'm assuming that you have liked my explanation and you have understood my explanation. So if it is true, then please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. Okay? And in case you have any doubt, any confusion, any query, please feel free to write to me in the comment area. I'll be trying to answer your questions. Okay? And so we meet again very soon in our next session. Till then, bye.